Hello and welcome. My name is Emeric Marl. I'm Senior Specialist in Clinical and Toxicological Application at SCIEX, and I will present this webinar dedicated to the new generation of QTOF, the high-resolution mass spectrometer, the SCIEX X500R. We will talk about the forensic toxicology analysis through the unique acquisition method called SWATH. The SCIEX X500R QTOF system is combined with a SCIEX Axion LC UHPLC chromatographic system. The analytical set is managed using the new SCIEX OS software. The instrument part composed of the Axion LC system is characterized by a complete control in the software SCIEX OS, which has allowed a better integration in the software solution and a better stability of use. The SCIEX X500R QTOF is characterized by innovations, among other things, at the level of the flight tube with a design of N-shaped optical paths and the stabilization of the temperature by heating. The entire design of the instrument minimized its size and was developed to facilitate its accessibility. The software part is based on a completely new platform, a new user interface integrating the capability for simultaneous processing of qualitative and quantitative analysis. This comprehensive solution enables automatic processing performed in the context of targeted and non-targeted unknown screenings. Here are some details of the new innovations made to the SCIEX X500R QTOF. A minimized instrument size allows it to be placed on a laboratory table or bench. Today, it's the most compact QTOF on the market. Its development has been conditioned by two important characteristics: simplicity and accessibility, in order to deliver optimal performance with ease of use and maintenance. The Turbo V source incorporating the twin spread probe and the automatic calibration system completes the set of improvements. The TOF part of the analyzer has also benefited from innovations. The ionic box is now N-shaped to obtain a very good resolution without compromising sensitivity. In order to maintain high mass accuracy and robustness of the system, the TOF is kept warm by 6 heated drones. In addition to this, the system is also able to use background ions to maintain mass stability dynamically without calibrating. In terms of ionization, the system uses the Turbo V source reference, but now incorporates a 2 electrodes probe. One electrode is connected to the liquid chromatography system, while the other is associated with the integrated calibration system to maintain the mass calibration automatically without interfering with the flow of samples. The X500R system allows the quantification of compounds thanks to the TOF-MS with very good mass accuracy, plus or minus 1 ppm. This slide shows you a linearity range on the ethoxylam compound between 0.5 and 1000 nanogram per milliliter. The system also allows a great stability of mass accuracy. In the example shown, injection of several drugs at different concentrations aided in 6 urine samples were analyzed for a period of 10 hours without calibration. The results show a mass accuracy around plus or minus 1 ppm even without calibration. In order to control this instrumental set and process the data acquired, a single software platform was developed to replace existing software. Analyst, MasterView, and Multiquant software have been replaced by a single interface called SCIEX OS. The interface and ergonomics have been redesigned for this new software. Improvements have made it possible to increase efficiency and productivity during the acquisition, analysis, and processing steps through this single interface. The software homepage contains a module on the left allowing the creation and implementation of analysis. At the center are the tools for qualitative and quantitative restatements. And finally, on the right, the configuration module for the software parameters. In the MS Tune menu, it is possible to perform automatic calibration in MS and MS-MS using the integrated system called CDS for Calibrant Delivery System. At the end of calibration, the software generates a report of results. The worklist creation part incorporates the automatic calibration function in order to regularly insert in the batches the check of the system. This slide shows you the waiting list of the samples with a visualization at the bottom of the current analysis. The right panel is used to monitor the real-time operating status of the system and to access to the manual control function of the instrument. After data acquisition and the processing steps, the SCIEX OS software is able to generate qualitative and quantitative result reports. Available templates can be edited to create reports in different formats. For the processing part, the software has also benefited from many improvements. The analytics module is based on a selection panel on the left that can manage a large list of compounds and/or samples. The result table contains intuitive filters necessary for easy visualization of the data. The MS and MS-MS identification and quantification information has also been integrated into the interface to improve efficiency and comfort when verifying the results. To illustrate the analytical capabilities of this new instrument platform, X500R, and the performance of our new software solution, I will present the example of a toxicological analysis using a unique acquisition mode called SWATH. Human urine was supplemented with 16 new psychoactive substances and then diluted by 10 before injection into the LC-MS system. The chromatographic conditions detailed here were done on a Kinetex phenylexide column from Phenomenex for a runtime per sample of 6.5 minutes. We employed a novel non-targeted analytical technique with the LC QTOF, providing highly selective MS-MS analysis of all analytes. Our method used the SWATH acquisition. It allows a sequentially acquire of MS-MS of all precursor ions across a specified mass range by passing the mass range into small windows. In every scan cycle, the instrument rapidly and sequentially acquires MS-MS of all mass windows across the specified mass range. Since the approach is non-targeted, our method should not acquire future modification for incorporating newly emerging compounds, and MS-MS spectra are acquired for unknown compounds that can be identified retrospectively via data interrogation. We specified a mass range for our SWATH MS-MS acquisition. Since synthetic cannabinoid masses fall between 232 and 406 Dalton, any emerging synthetic cannabinoid with a mass between 228 and 408 Dalton also will be detected via this method with a high degree of selectivity and sensitivity. If we compare the IDA method usually used to perform screening with SWATH, we can see that these two methods use TOF-MS acquisition in order to detect the compounds of interest. However, IDA triggers MS-MS detection only if the candidate ions of interest exceed a defined intensity threshold. During SWATH, MS-MS detection is triggered throughout the analysis on all compounds over the entire selected mass range. This slide summarizes the architecture of the two acquisition methods. In the example presented here, we observe the presence of two isomeric compounds whose chromatographic retention times are very close. Thanks to the SWATH acquisition, the MS-MS spectra of the two compounds made it possible to identify the two compounds distinctly with a high level of confidence. Thanks to the SWATH, it is also possible to use the identification of the compounds during the MS-MS thanks to the use of unique ion fragments and their ratios. We can see in this example two compounds, two metabolites of catenin with two different retention time, and for each compound a unique fragment for identification and the ratio to identify the full spectrum. In this way, it is possible to improve the identification of different isomeric compounds and contribute to a better specificity. The choice of a relevant fragment will make it possible to minimize the interferences and the level of background noise that can be observed in MS, which will make the quantification more efficient. In the example shown here, 3 isomeric compounds have been detected in MS, and only the compound whose fragment 117 is unique will allow a very specific detection and quantification by MS-MS. Thanks to the choice of a fragment having a high specificity for a compound, the interferences can be eliminated, which makes it possible to better integration and quantify more precisely and reproducibly, as in the case of the compounds methoxyethamine. The SWATH acquisition method is created over a TOF-MS acquisition mass range from 40 to 500 Dalton, for example, allowing to obtain 16 windows of variable size for MS-MS between 120 and 500 Dalton. The processing methods were then created. The list of targeted compounds has been defined with their expected retention time, exact mass, precursor ion, and specific fragment. The library search parameters and the identification criteria were then also defined, like mass, error in ppm, error in retention time, percentage in difference between the isotopic patterns, and the library hit score for the comparison of spectra. Once the analyses were performed, the processing methods was used to generate the following result table. If calibrators are associated with the results, this directly leads to a quantitative analysis of the targeted compounds. You will find in the various panels the information for peaks integration, calibration curves, isotopic patterns, and library search comparisons. Traffic lights also tell you the result of each criterion, allowing the identification of the compounds in the result table. It is then possible to demonstrate positive results thanks flags, for example, by means of a calculated concentration threshold. The display of the result table can then be filtered according to the sample type and the desired acceptor levels. This allows you, for example, to show only the positive compounds of the unknown samples according to the chosen acceptor criterion. Here a calculated concentration threshold. In the various panels, you find for this unknown sample the qualitative and quantitative result of the positive compound found. By comparing the ion ratio with the standard calibrator samples and comparing the MS-MS spectra with the library, a single compound was identified in the urine sample, the N-ethylcatenon ephedrine metabolite. Finally, quantification could be obtained as much from the precursor ion as from the fragment ion as well. Here is another example of qualitative and quantitative result targeted to the compound alpha PVP obtained under the same circumstances through the SWATH acquisition. You can see the different standard samples at different concentration from 0.5 to 2000 nanogram per milliliters. And there we have the ion ratio chromatograms for calibrators with tolerance lines. We will continue with another example illustrating the performance of SWATH analysis in forensic toxicology screening on hair matrix. The procedure is preparing the samples consisted in extracting the compounds of interest from 20 mg of hair according to the above article. An injection volume of 10 microliters was then used for the LC-MS analysis. The procedure, the calibrator were prepared between 5 picogram per milligram and 2.5 nanogram per milligram. The chromatographic conditions details here were carried out on a Kinetex phenylhexyl column from Phenomenex for an analysis time per sample of 6.5 minutes. The norcocaine was identified in the unknown sample by the retention time, the iron ratio comparison, the mass accuracy of the precursor ion, the comparison of the isotopic pattern, and the research of the MS-MS spectrum in the laboratory. Quantification of norcocaine showed a good linearity, a good measurement accuracy, and reproducibility with a good statistics result in percentage of CV and accuracy. Here are another results on methamphetamine with the calibration curve, the statistic results table, and the ion ratio calculation with tolerance lines on chromatograms. Here is another example with 2 ions for a compound, the compounds MDA, and the quantification with the calibration curves at the bottom. Another result of the identification of EDDP thanks to the ion ratio, the expected retention time, the mass error, the isotopic pattern, and of course the MS-MS library matching. The 6-MAM compound has been identified and quantified as well. Cocaethylene, cocaine with a good accuracy and linearity for quantitation, and finally heroin compound. In summary, the Xeon LC and X500R solution coupled with the SCIEX OS software platform enables highly targeted and non-targeted toxicological screening analysis. The SWATH analytical approach is unique to the QTOF SCIEX system and opens up new possibilities and enables the simultaneous implementation of qualitative and quantitative analysis without any compromise. Thank you for your attention. And now, to finish this presentation, I will show you some details and key elements of the SCIEX OS software by live directly with the software interface. Here is the interface of the software SCIEX OS. You can see that at the left you have the acquisition module with the LT method and MS method menu to create and to modify the methods. The MS tune allows to calibrate the mass spec, and then you have the batch creation and the queue list to follow batch after batch your analysis. In the middle you have the processing module with the Explorer and the analytics to process the qualitative and quantitative results. And at the right you have the management module allowing to configure the parameters of the software. At the right you have the panel to see in real time the status of the mass spec and the LC as well, the queue, and of course to be able to choose your projects and to have a direct control of your system. First, we can go through the LC method creation, where you can open your method directly, create your method from scratch, and modify your method for DLC. All modules are separated by tabs. First, you have the gradient for the pumps with the program, the flow program, and the settings for the purge and for the solvents, the flow rate, the concentration, and of course the pressure limits. For the autosampler, you can modify and change the parameters for the rinse settings and the settings for the rack and or other settings, especially for the sampler. For the column oven, you can choose the oven temperature and the limits. And of course, if you have two valves or one valve in the oven, you can select it and use it to switch column, for example. And then the last module is the controller to manage all the other modules in the LC. You can save the method and use it then. For the MS method menu, this is the same. You can create from scratch a new method with different experiments from TOF-MS to the guided MRM-HR and for SWATH and TOF-MS too. You can open a method and save it to use it. For this example, we have the SWATH method in 6.5 minutes runtime. You have the gas and source parameters, and then the experiment of SWATH. In SWATH, you have first an experiment for TOF-MS, and then TOF-MS with different windows. You can see the windows there, 29 windows, from 30 Dalton to 500 Dalton for the MS. The total scan time is less than 1 second for everything, TOF-MS and MS, all over the chromatography. After that, you can go to MS-Tune to calibrate the system if you want with a tuning procedure. We have different tuning procedures in positive and negative for Q1 or TOF-MS system. At the end, you can generate a report of the calibration. Then you can go to the batch. Here is a already filled batch. We can use, save, modify as you want, and submit it in the queue. Of course, you can activate the auto-calibration, allowing to calibrate for every 5 or 10 samples, thanks to the CDS, to maintain the accuracy at 1 ppm maximum. You can click on Submit, and you can see directly in the queue the batch there, and batch after batch you can see the result in real time during the run. You can start the acquisition, and during the acquisition in real time you can see at the bottom the TIC and the spectrum already in this panel. At the end of your batch, for example, you can process it and you can explore the data directly, and you can open it and go deeper and through the raw data if you want. You can close it. For data acquisition in real time, you can see for all panels you can see the data acquisition, but even for the processing. And as soon as you have you have processed your raw data, you can go directly to the analytics, and you can open the results and create the result. For example, here the result is the result table generated for the example in the presentation before. You can see at the left you have the samples directly. There you can choose and select it. And you have a tab to select the components and the groups, to select specially a compound. And for this example, we have the N-alkylcatenon metabolite, where we have some standard analytes, for this compound, and 3 unknown samples, A, B, and C. You can see that you have the result for the quantitation and the identification with the criteria of mass error, retention time confidence, isotopic confidence, and deliberate confidence. And you can explore and process the results thanks to the filters. For example, I can select only my unknowns. You can see I selected my unknowns. You can see that the calculated concentration is only for unknown A, and it indicates that I have a positive result for this compound only for the unknown sample A. I can change the acceptance criteria for the calculated concentration, for example, and then through this I can select only my positive result. And to explore the qualitative result and quantitative result of this compound, I can open the panel for the peak review and the panel for the calibration curve. And you can see that I have a good linearity from standards and of this compound. And at the bottom, I can see the qualitative results that I can open and undock it to see the shape of the peak of the chromatography of this compound, the retention time compared with the expected retention time. In the middle, I have the comparison, the overlay of the isotopic pattern. And then at the right, I can check the identification by comparison with library. And I have the confirmation that the compound is the N-acetylcatenon ephedrine metabolite with a very good fit, reverse fit, and at the end, a very good purity. Thanks to this processing, I have a very good confidence in identification, and I'm able to quantify directly my compound in this unknown sample. At the end of the processing, I can create a report with the reporting feature. I can create the report and save the results table. I select, for example, a template. I can see an example there with tables, chromatogram, and spectrum comparison. I select the report format in docx for Word, PDF, CSV, or HTML. I can create an individual report for each sample if I want. And then when I click create, I generate the final report. In addition to the report creation, I can transfer the result directly to the LIMS thanks to this feature. And this feature is directly configured in the menu for configuration management. I can go directly in this module with the general parameters, the LIMS communication configuration for the communication through the middleware between LIMS and the SCIEX OS software. I can manage the devices and to activate and deactivate the LC-MS configuration. Here is the Xeon LC coupled with X500R QTOF. And I can manage some parameters for the queue. We have the event log from Windows to follow each change or things you do in the software. Everything is followed. And then the last menu is the users management to select and to activate or deactivate different users for the security access of the software. That's it. it was an overview of the SCIEX OS software. I hope that it will be useful for you to understand how it's very powerful software and very powerful association with the X500R QTOF and Action LC in the toxicological, the forensics screening field. And talk to you soon for another webinars in the future. Thank you very much. Bye-bye.